Welcome everybody to video 4 of Unit 1. This is by far the most important video that I'm going to shoot for this particular unit because it really has the crux of everything that you need to know. This is called the factor label method, or sometimes textbooks will call it dimensional analysis. It is the key skill that you need to master for this unit in order to be successful. The range of skill is from very simple, straightforward, easy problems to much more complex problems that require you to be able to read, analyze, and then take action and solve the problem. I will be incorporating things like geometry into this. I'll be incorporating algebra. But mainly, it's just about being careful, about looking at a problem, picking out the relevant information. I recommend for this that you pause this video frequently and then you look and you see, well, what did he do here? And then you try it on your own. And you should be able to solve these math problems on your own. Now, our first problem is going to be a simple one. Something like, how many milliliters are there in 5 meters? Well, I'm starting with 5 meters. And so when I write this, I write the number and I write the unit, 5 meters. And I want to change it to milliliters. I want to get this equal to milliliters. So I'm going from meters to millimeters. Now I need to be able to convert the 5 meters to millimeters. And to do that, I need a dimension. I need a factor with a label. Well, I know from before, in our previous day's notes, that when I look at my prefixes, they're both metric, millimeters and meters. And I look at milli, and I see milli here is 10 to the negative 3. Well, what does that mean exactly? What that means is that, and I'll do this on the side, if I were to have 1 meter, I would have 1,000 millimeters. Or, as it's written in the chart, if I were to have 1 millimeter, I would have 0.001 meter. You could use either of these because they mean the same thing. The difference between them is that, this is 1 millimeter just to be clear. The difference between these two is I took this one here and I divided it by 1,000 and I got this. You could use either one. And I'll show you, I've listed them in both ways on the notes so that you can use which one you're comfortable with. Now I need to change from meters to millimeters. So I multiply the meters by some kind of factor. The factor, in order for it to work, this has to be equivalent to 1. You've learned this in math, that you can multiply any number by 1 or its equivalent of 1 and it will stay the same. This is a little bit different. The fact that 1 meter is equal to 1,000 millimeters, if I write it as a fraction, I can write it as 1 meter over 1,000 millimeters, or I could write it as 1,000 millimeters over 1 meter. Because they're equal, 1 meter is equal to 1,000 millimeters. Because they are equal, I can write them so that if they're a fraction, they will be equivalent to 1. So when I look at this, I want to put one of these fractions into my parentheses. I want to get rid of meters, so the meters would go on the bottom. I want to convert to millimeters, that would go on the top. Well, for meters, the number that goes in front is 1, and for millimeters, it's 1,000. I use this fraction. If I take 5 meters and change it to millimeters, I multiply 5 times 1,000 divided by 1. The meters cross out, and I am left with 5,000 millimeters. How can we put what I did into words? Look, at this point, if you're looking at this and you're like, what did he do? Replay this part of the video. Go through it. Do it as many times as you need to until you see why this works. We're going to do a lot more examples. If you want to put this into words, though, in dimensional analysis, you're going to treat the units just like their numbers. So if I put a unit on the bottom here, meters, and I have a unit on top, meters, they act like numbers. They can cross each other out. If you want to convert from one unit to another, you need to use a conversion factor. Whatever unit you want to cross out has to be on opposite sides of the fraction. What that means is that if I have meters on top and I want to get rid of it, I need to put meters on the bottom. Whatever I want to change into, I would put on the same side. The idea is you're getting out with the old, in with the new. So here's one for you to try this out. People are able to do this problem. They know it. How do you measure a year in minutes? And what I want you to do is I want you to pause the video right now and I want you to try. I want you to take 1 year and I want you to convert it to how many minutes? So hopefully you paused the video and you tried this. A lot of you probably just wrote down an answer and didn't show your work. You must show your work. If you need to, pause the video again, try it now, show your work. All right, let's see how your work measures up to mine. Well, I know some things about time. What are my factors? What are my analyses, my dimensional analyses here? Well, my factors include these. I know that in 1 year, there are approximately 365 days. You might have used 365.25, that's great. I also know that in 1 day, there is 24 hours. I also know that in 1 hour, there are 60 minutes. So I have all of the things I need to go from years to days, days to hours, hours to minutes. It's almost like I'm following along here on a road. Years to days, days to hours, hours to minutes. So let's see if we can figure that out. Let's see if we can go ahead and work this out. So let's say that I were to have 1 year. Well, I want to convert this to days because that's what I have a day and a year equal to. That's the thing that connects them. I want to get rid of my years. It would go on the bottom. 1 year has 365 days. My years will cross out. If I then want to change days to hours, I know that for every 1 day, there are 24 minutes. And I know that if I want to change, 24 hours. If I know that if I want to change hours to minutes, I know that for every 1 hour, there's 60 minutes. Now all I have to do is cross out days, days, hours, hours, and be left with minutes. If I do that and I get my answer, then I would have 365 times 1 times 24 times 60 and that would equal 525,600 minutes. Maybe you know this reference. If you've seen any Broadway shows, I will spare you my singing of it so that you will continue to watch the video. So now, what type of conversions are we doing here in our class? Well, you can see that we have this one where we were doing time. We started off with 1 year, we converted it to minutes. But I could also do other types of conversions. I could do something like length, where I have meters and I convert it to inches, feet, yards, miles. I could do volume, liters to gallons. I could do mass, where I do grams, changing to pounds. And so you can see that we have a bunch of different conversions that we can do. And so in order to be able to do them successfully, you need to be able to know the conversion factors. And what are the conversion factors? Well, they're listed down here. So here are the conversion factors for these different types of conversions. And so you can see, for example, if I have mass here, I have 1 pound, and that's 454 grams, or 16 ounces. So I could ask you something like, well, if you had a substance that weighed 323 grams, and I ask you, well, how many ounces is that? So I want to go from grams to ounces. So how can I do that? Well, let's look at this. So 323 grams. I start with that number. What am I going to multiply it by? If you want at this point and you feel comfortable, pause the video, try it out, see if you can get to ounces. So let's see how I'm going to do this. If you pause the video and you have an answer, let's compare answers. If you're not sure what to do, look closely here. Then pause the video, try it on your own, and I'll do another example with you after that. So 323 grams, right? So I could do this in 2 steps. I could say, well, I could go from grams to pounds. So I could say, well, for every 1 pound, there's 454 grams, because there is. 1 pound is 454 grams. I see that right here. Well, now I would have my answer in pounds. The grams would cross out. Well, I want to go from pounds to ounces. Well, for every 1 pound, there's 16 ounces. So now if I were to do this, I would have to put into my calculator 323 divided by 454, enter, times 16, and I would have 11.38, or 11.4 if you round correctly. We'll get to rounding later, and that would be in ounces. This is my work, what I just boxed in here, and this is my answer, what I just circled. In order to get credit on one of these types of problems, you need to show both your work and your answer. Here are the metric conversions down here that I'm highlighting. And here are the geometry equations that you need to know for volume and circumference of a circle, volume of a cylinder, volume of a sphere. So you can see I did this in meters, these different conversions here. Well, what this shows me is that each one of these is equal to 1 meter. This is a little bit different from the chart that we had above. If I scroll up to show you the conversion factors from the other day, here are different conversion factors, and they're doing it where they have, instead of 1 meter equal to each of these things, they have 1 decimeter is this many meters. It's up to you how you want to do it. I'll show you both ways. I normally use, sorry, let me just scroll back down here. I normally use what I highlighted down here. So I normally use the positive exponents. And so an example of this would be, let's say that I wanted to go from something that was 50 centimeters, and I want to make this into nanometers. Well, if I know the factors here that I will now put in blue, I know for nanometers I have this factor, and centimeters I have this factor. Well, look at how this could work in one step, 50 centimeters. If I know the prefixes nanometers and centimeters. Notice I put the centimeters on the bottom. Nanometers, the prefix is 10 to the 9th. Centimeters, the prefix is 10 to the 2nd. Remember, when you divide with exponents, what do you do with them? That's right, you subtract. So that would be 10 to the 7th times 50. So 50 times 10 to the 7th, or 5 times 10 to the 8th, and the units would be nanometers. There's a difference between not understanding how to do this and not putting in the work to do it. Come in tomorrow with these conversion factors memorized. Know how to use them. If I gave these to you conceptually, you should be able to do it. If you can't do it conceptually, then we need to talk further and you need to practice more. Let's try a little bit more difficult problem here. Practice with dimensional analysis. What is the speed of light? 3 times 10 to the 8 meters per second in miles per hour. So now I have this huge number, 3 times 10 to the 8 meters per second, over seconds, over 1 second. I want to change it to miles per hour. Well, go and take a look if you have to at the chart. I know, because I've memorized these, that there are in fact 1,600 meters, or 1,610 meters. Let's do that exact. Just erase this 0 here. 1,610 meters for every 1 mile. So my meters will cross out with my meters. But I want to get this per hour. So instead of seconds, I want the seconds to cross out. This is really important. Notice the seconds, they're in the denominator. So I need to put seconds up here to cross out with seconds, and hours down here. Well, how many seconds are there in an hour? Well, there's 3,600 seconds in 1 hour. You could have done hours to minutes, minutes to seconds in 2 steps, but I do it in 1 step. So now I go ahead and I try this. So I have 3 times 10 to the 8th. 3 times 10 to the 8th times 3,600 divided by 1610. And I get 670,807,453 miles per hour. It's a lot of miles per hour. Speed of light. Cosmic speed limit. If I put this into scientific notation, 3, 6, 7, 8, I have 6.7 times 10 to the 8th miles per hour. Take a second, look at this, go back, try it on your own. This is just like any other activity. You need to practice to get better. If you don't practice, you don't get better. This one was a little bit more difficult. Think to yourself, why is it more difficult? Let's talk about that when you come into class. What made this problem more difficult? Let's look and see what we have with the second practice problem here. Now, this is a problem that's a little bit more challenging. An atom has a radius of 90 picometers. So here's my atom. Its radius, if we zoom in here, is 90 picometers. How many of these would be required to form a line 1 mile long? So now I want to take these and I want to line them up until we're at 1 mile. Just touching edge to edge. Now when I look at this problem, there's a shape here. The shape is a circle. The circle has a radius. So the first thing I say is, well, each atom, how wide is it across? What's its diameter? Double the radius, 180 picometers per atom. Now the question asks me how many atoms are going to be 1 mile long. So I have one atom equal to 180 picometers. Well, how many atoms, question mark atoms, are going to be 1 mile? The way I wrote this out, what's the problem with just looking at it this way? Think about that. When I look at this, I say, well, the distances aren't the same. So we need to change up the distances. So I could either make miles into picometers or picometers into miles. I'm going to make miles into picometers. It doesn't really matter which one you do. So 1 mile times 1,609 meters for every 1 mile times 10 to the 9 picometers for every 1 meter. And when I do this, I'm going to get 1.609 times 10 to the 12th picometers. This is how long my distance is. Well, if I have 1.6 times 10 to the 12th picometers, and I multiply that by 1 atom for every 180 picometers, picometers will cross out, and I'll be left with atoms. So if I do that, and I get 1.6 times 10 to the 12th divided by 180, I will get 8.9 times 10 to the 369 atoms. This one's a little bit different than what we did before because I actually made up a conversion factor here. This right here, 1 atom is equal to 180 picometers. That's a conversion factor. The difference is that it's not one on the page. It's one that's sort of in the problem. So now that you've watched this video, and you may need to watch it a few times, try this next one. Come in tomorrow, see how you do. To give you a little hint here with this one, there's a shape. Start with what is the shape. Figure it out, try out the problem. Good luck. We'll talk tomorrow, and we'll go over some more problems in class. Thanks so much.